All right, thank you, everybody. Sorry about that. Welcome, thanks for coming. I am Aaron Parecki, and here to talk about the state of OAuth. And the clicker works too, that's wonderful. I'm a senior security architect at Okta. I do a lot of education on OAuth and OpenID concepts, and I also actually participate in the OAuth group at the IETF, where we actually have a lot of these discussions and work on advancing the protocols and advancing the state of things. So you might be familiar with OAuth from its use in these kinds of sign-in, social sign-in buttons. And that's how it really got its start quite a long time ago now. And this is OAuth, but this is kind of one of the older, more traditional uses of it. It's not necessarily how OAuth is actually being used today. It's being used in a lot of different ways that have gone far beyond this original use case. The original reason that that was created was because before we had that pattern, this was how things worked online. An app would launch, in this case Yelp, and it would say, hey, are your friends already on Yelp? Where is that data? That data is in your email. It's your contact book, your contact list. So Yelp wanted access to your email or your contact list, and the way it would get that access is by asking you for your password to your email. And it would log in as you, download the data it needs, and then hopefully, not save your password or do any other bad things. And you were just kind of trusting that it would behave correctly, which a lot of things obviously did, and a lot of things obviously did not. So it's that idea of, do we actually want to just blindly trust these third-party apps to to get only the data they need? Ideally, no, we should not only trust them. We should actually have mechanisms in place to prevent them from accessing the things they don't need. So we're not going to change the behavior of users wanting to share that data. So we need to provide a way that users can share the data that they want to share with this application, but prevent that data, other data, unrelated data, from being actually accessed by this application as well. And this was the original idea with OAuth, was granting this permission to access data to third-party applications. So actually, as Christina mentioned, this hotel analogy comes in handy here as well. When you go to the hotel and you check in at the front desk, you show that person your ID, proving who you are, and you're saying, I'm showing up here and I want access to some resources in the hotel. They give you this hotel key, and that gives you limited access to certain rooms in the hotel. So you can't just go around and open up every door with that key. It's going to let you access only certain doors. So it's that same idea of downscoping or limited access to resources. And if we bring this to the OAuth world, the person at the front desk is the authorization server handing out these key cards, issuing these key cards, which you could think of as a type of token. That token grants access to resources, which would be the doors. This is really where things started. And this is OAuth 2. That was, OAuth 1 actually was for the same general purpose, but it worked in a completely different way under the hood. OAuth 2, that's really where things started. Like, let's be able to grant this limited capability tokens to applications. So now, instead of handing passwords out to these apps, we have, the user goes to this application, gets redirected to the OAuth server. That's where they sign in. That's where they enter their password. That's where they do their multi-factor authentication. And eventually they get redirected back to the application. Now, you may notice that in this case, I've actually got Google on both sides of this, because it turns out that while originally the idea was this is going to protect against third-party apps, we're going to prevent third-party apps from getting access to data they don't need, it actually has a lot of benefits in the first-party case as well. So Gmail, for example, if you've noticed and you go to Gmail and you click sign in, you don't give your Google password to Gmail. Gmail is an application. It's a first-party app, also made by Google, but it doesn't ever actually ask you for your Google password. Instead, it sends you out to the OAuth server, and that's where you enter your password. So this is the way that we can insert this consent step of asking the user, is it okay to share this data with a third-party app? You may not want that consent step for a first-party case, because it doesn't really make sense for Google to ask you for permission to share data with Gmail, because that just sort of is all under the same umbrella. but the same concepts apply and the same redirect patterns work in both cases. So we're going to come back to this diagram quite a lot, so I want to take just a very quick moment to go through it. This is generally how the OAuth flow works. We've got a couple of different players involved. Does this have a laser on it? No. The user is the one that's operating this, this client, this application. They're also going to be interacting with their own browser. And each of these arrows is a different piece of software talking to another piece of software. So I'm not going to go through the entire flow because that's not the main point here. There's plenty of other videos online about how OAuth works and stepping through the redirects and all that. But the point here is that what I do want to point out here, because I'm going to be using this as a reference throughout the rest of this, is that each of these steps has certain properties of who's talking to who, and we may change some of those properties by adding new extensions from the OAuth world. The main thing here is we've got the client that starts by, I should have put numbers on them so they're at least in order, but the client is going to be sending the user in their browser to the authorization server, which then sends them back to the client with that little lightning bolt, which is an authorization code. The client then exchanges that for an access token, and they get the access token in the response from the authorization server, which they can then use to make API requests across the bottom, which the resource server then has to somehow validate that access token, which is those next vertical lines. So we're going to come back to this in a bit. So we start with the OAuth core specification, OAuth 2.0, RFC 6749. It defines a couple of different variations of that diagram and different ways to get a token. It doesn't say anything about what happens after the token is issued. That's in a separate draft called bearer tokens. The idea with the bearer token is that if you have it, you can use it. So bearer tokens are defined in a separate draft for reasons that are complicated and mostly not relevant anymore. But the point is it's a separate draft. And the idea there was the core says how to get a token, bearer token says what this type of token is, mainly that it is like a hotel key card. If you have it, you can use it. There's nothing proving that you were the one that it was issued to once you've got that token. So then, around this time, the whole mobile ecosystem and JavaScript ecosystem was starting to really get a lot bigger, got a lot more popular, and there are some interesting constraints about these environments that weren't necessarily thought of originally or have changed since the original assumptions made in OAuth. One of the big things that a lot of the current work is focused on is reducing the use of what we call the front channel. This is essentially passing data in a redirect. So in that flow diagram, eventually at some point, the authorization server wants to send something back to the client, and it doesn't have a way to push it directly. So instead, it sends it in a redirect through the user's browser. And I like to think of that like sending a letter in the mail, because just like it's really the two pieces of software trying to talk to each other, but they actually have this third-party delivery mechanism in the way. It's the browser. That's what's going to be actually sending the data between the two pieces of software. So like a letter in the mail, if you send one, do you actually know it was received? Do you know that it wasn't copied along the way? There's no way for you to actually prove that as the person who sent the letter in the mail. And similarly, on the receiving end, do you know it's actually from who you think it's from? You can't actually prove it. You may get a tracking number, which provides some information, but it's definitely no guarantee. It's only as much as you're trusting the delivery company. It may have a return address, which is pretty much meaningless. So there's no actual way on either end of the transaction to really be sure that the transaction was successful, which means anytime we use the front channel, we have to do something to add back that missing information. We need to do something so that we can be sure that both the sender and the receiver are the expected parties and the expected thing happened. So that is, for example, why we don't use the implicit flow in OAuth, because the implicit flow sends the access token itself in the front channel, which means we're missing information on both sides of was it received, was it stolen, is it from the right OAuth server? That information is all missing. Instead, we still send the authorization code in the front channel because we kind of have to. And there's a couple of other front channel things as well, which we can and are starting to sort of phase out. So this was one of the first things that addressed the front channel, Pixie. This was meant to add in that missing information of did this code that I sent back to the client arrive at the correct client? And is that client the same one that's using the code to redeem it for a token? Then came a recommendation saying, please do this now for mobile devices. They kind of went hand in hand there. Then, as these browsers started getting old and showing their age and better browsers were coming along, it suddenly became possible to do Pixie in a browser, which wasn't the case originally when cross-origin resource sharing wasn't really possible. Now that cross-origin resource sharing isn't really a big deal anymore, we do it all the time, we can do this in a browser. So that basically means the implicit flow, which was always a workaround for the lack of the ability to do the authorization code flow, doesn't really serve any purpose, so we don't need it anymore. And now if you look at the security BCP, basically what it says is use Pixie for mobile apps, for server-side apps, because of these other front channel issues. Don't use the implicit flow, don't use the password flow, et cetera, et cetera. So this looks kind of messy, and you're probably thinking, what a giant mess, who thought of this? And there's a lot of stuff going on, but it isn't actually as bad as it looks in this picture, because if you condense all of that down, what you've actually got is just a relatively straightforward list of what OAuth 2 actually is now. And this is what we're trying to capture in OAuth 2.1, of sort of the original OAuth minus the stuff that we don't need anymore because it was always a workaround, plus a couple of the new good things that have come along since then. So that's OAuth 2.1. We're trying to consolidate the best practices, capture the current best practices, add references to extensions that didn't exist when OAuth was originally created, because there's been a lot of new work both in OAuth and in related communities. OAuth 2.1 is not trying to actually make new things happen. It's meant to only capture the current things that are already happening in OAuth 2. And that's critical here, because what it means is that if you are today following the best practices of OAuth 2 in your implementations, you are already doing OAuth 2.1. That's the whole idea with that. It's not meant to say you need to go and rewrite everything for OAuth 2.1. But there's more. There's a lot more work going on, and we can look at how the new extensions fit into the rest of the OAuth flows. One of the recent additions to the collection of RFCs of OAuth is the JSON Web Token profile for access tokens. This was a lot of Vittorio's doing. And the idea here is that while even the bearer token spec itself did not define a format for access tokens, it defined the concept of a bearer token rather than a key-bound token. The format for access tokens was left undefined until really this draft, because it turns out a lot of people ended up doing the same thing, which is a good candidate for turning something into a standard. This essentially formalizes the use of a JSON Web Token as access tokens, talking about maybe some particular claims you should put in there, what they mean, some considerations about what happens if you do this or don't do this. And this is where it fits into that diagram. It's essentially the contract between the resource server and the authorization server. So it's defining the format between those two. And now they have a shared language that they can use, and you get a lot of interesting properties once you can solidify on that format. Whoa. OK, so yes, that's where I was. Pushed authorization requests, also a new RFC. You're noticing these RFC numbers are getting dangerously close to 10,000. And then I'm sure a lot of databases will break when they assumed they could only have 4 numbers. Pushed authorization requests. So the idea with this one is, again, this is addressing the use of the front channel. Typically, in OAuth, the authorization code flow, or actually most flows, will start the OAuth flow in the front channel. It starts by the application building a URL with the authorization server's URL, starting with the authorization server URL and a bunch of query string parameters, sending that as a redirect to the user's browser. The user's browser delivers that to the OAuth server. What's actually happening there is the client is trying to tell the OAuth server stuff. It's trying to tell the OAuth server, here's my client ID, here's where to send the user back to, here's the scopes I'm requesting, and maybe more things that you're starting to add to that query string. Because it's in the front channel, the OAuth server doesn't really have any way to know at the time it's received that request came from the client, because the user can modify it, right? If you start an OAuth flow with your own account, try it sometime. See what URL you land on, and then just change parameters up there and see what happens, right? you can make interesting things happen. Push authorization requests, the idea is to start the flow in the back channel to avoid putting all that information in the front channel, both because then you can prevent clients from modifying it, but also because as we start to cram more and more stuff into this first part of the request, it starts to get kind of long. So that is changing the way the flow starts, and we start now with a new line in yellow between the client and the authorization server, starting the flow in the back channel. Then it gets this thing that represents the data it just sent, and then it does sort of the regular flow with, instead of the full data, a representation of that data in the front channel. So yeah, instead of the typical OAuth authorize response type code, client ID, blah, 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 you would post all that and then get back some opaque string. Another one, JOT authorization request, JAR. Similar, addressing a similar part of the flow, but for different reasons. So this one is, instead of posting the data as just form data, it would instead take all that data that it would have sent in the front channel, turn it into a JOT, sign it itself, and then send that to the OAuth server somehow. And that could either be through a redirect, because now it's a signed JOT. The OAuth server can verify that that request was from the OAuth client and not tampered with, because it's signed now. Or you could actually post that in the back channel also. Another one, authorization server issuer identification. This one's a funny one because it's so small. It defines just one parameter that does one particular thing, and it actually went really quickly through the whole process because of that. But essentially, if your OAuth client ever talks to multiple authorization servers but has only one redirect URL, then again, because of this front channel issue, when you receive the redirect at that redirect URL, that's from the front channel, which means you don't actually know where the response came from, because it came from the browser, not from the OAuth server, and you are now at risk of a mix-up attack. This adds a single parameter that solves that attack for this very particular use case. So that fits into that leg of the response. Oops. That's in the wrong spot. That's my bad. It should have been to the left and down. It's in the redirect. Rich authorization requests. Here's another fun one. This one is pending its RFC number, not quite yet, but very, very close. The idea with rich authorization requests is that scope in OAuth is kind of limited in terms of the use cases that it can address. Scope is how the app says, I want access to your email or your contacts or those kinds of sort of fixed buckets of information. And scope has worked fine for that. As we're trying to push OAuth into more and more complicated use cases, there are a bunch of limits to what scope can express. Mainly, it can't express things that change or that are just variable by nature. For example, if you wanted to say, I would like to authorize this app to transfer up to $1,000, you might be able to express that in a scope, but if only really in buckets, because you wouldn't want to pre-register every single dollar amount as a scope. But especially once you start getting into I want to let this app move $20 from this account to that account, that just kind of breaks down. So the idea here is we want to enable authorization prompts like this to be able to express more complicated transactions in an OAuth consent screen. So this is a mechanism for containing that request. It could look something like this. I think this is a snippet from the spec. But it's here is the type of request, here's the details of the account from and to. The vocabulary is sort of up to anybody to create for their own use case, but this is the sort of level of complexity you would expect to see in a rich authorization request. Okay, another one, JOT response for OAuth token introspection. That's a really long name. This one is when a resource server wants to know, is this access token valid and what does it contain? It can send that token to the OAuth server's introspection endpoint and get a response back. That response would just be a list of properties. This defines the response as a, oh, I didn't put the little on the leg diagram there. This defines the response as a JSON Web Token, which is signed by the OAuth server, which means it can be logged in its entirety, and you can then demonstrate later that the OAuth server did in fact say this token was valid at this time and prove it. Okay, a couple of things that are in progress. Those ones were all pretty much finalized, more or less. Some of the more in progress and experimental stuff. This is still an ongoing problem, bearer tokens. We haven't really solved this as a general statement. The problem is bearer tokens, like a hotel key, anybody can use them if you have it. Which means if you can steal one, you can go and use it, and you've kind of bypassed everything else. You've bypassed MFA, you've bypassed everything, right? So we would like to require some sort of authentication of the client that is using a token before it is able to be used. Emphasis on some sort of and what actually client instance means. These are the kind of big question marks right now. There are a whole bunch of drafts for this problem. The three that are highlighted in yellow are the ones that are relevant right now. The two at the bottom are expired drafts, never really made it past just being a draft. Mutual TLS is the only RFC. This one has been an RFC for a while. It is deployed by plenty of people. It has some particular challenges when you deploy something with MTLS. There are constraints. It may not work for your environment. A lot of people aren't happy with it, so they're looking for alternatives. Depop is an attempt to do this. It's also very near publication. It's an attempt to use a private key to sign a request when you're using an access token so that you can't just steal an access token. That's meant to solve this problem at the application layer, like you would write it into your OAuth application. You would expect to be doing it sort of at that layer of the stack. It's also really meant to be usable in browsers in a way that mutual TLS really isn't usable in browsers. Signed HTTP requests is similar in architecture to Depop in terms of you have a private key, you use it to sign stuff, you put that into an HTTP header. That is not necessarily tied to OAuth, where Depop is 100% tied to OAuth. Signed HTTP request is meant to be generic and work with any HTTP request and then could be applied to OAuth. So that's actually in the HTTP working group right now, not even in the OAuth group yet. Yes, we talked about Depop, and it is, again, specifically for OAuth. It's defined in the context of OAuth, whereas HTTP signatures is general purpose, not defined for OAuth, but could be profiled for OAuth. In practice, they kind of look similar because they both use a key to create a signature, which then gets put in a header. Step-up authentication. I think that's actually what Vittorio is talking about next, so I won't spend too much time on this, but this is when a resource server wants to say, I actually don't want to trust this access token for various reasons. It doesn't have the right, whatever, policies that it's defined. Vittorio will get into more of that. The idea is that the resource server says, I need a new access token. I want the user to authenticate again or to get new claims or to get new scopes or whatever it is. And it's a way to actually signal that down to the client, which until now hasn't really been standardized. And I will leave it at that. I think we have 1 minute for questions before I hand it back over to Vittorio, or we can just hand it over right now since we're already running late. Thank you very much.